Network layer privacy. So the peer-to-peer network in blockchains is a loosely connected network where peers can join and leave at any point in time. So we have a certain set of validating nodes. We have also lightweight clients, and we do have miners, for instances. So this is the distribution of globally reachable nodes in the Bitcoin network. And this is in a screenshot from 2019. And this is not necessarily... this does not necessarily mean that these are all the nodes. These are the publicly visible nodes that have an open port on TCP port 8333. So this is what you can kind of reach, the network that you can reach. Behind that, there are many more lightweight clients probably, and also a certain set of miners. So what happens now is, if you know that somebody here is issuing a transaction and is propagating, let's say in this direction, it's propagating here across the world, right? It might be propagating here. At some point it goes there, and at some point it might reach here, maybe Europe, right? So these peers, they will receive it from some peer here, but the peers that are the closest, so the critical ones here, they will understand, oh, this is something that I've just received recently from a close by peer. So it is possible to kind of nail down from which area or from what are the possible candidates that sent me this transaction first. So this network layer data does disclose quite a lot of information. So what we can see are basically the IP addresses of the other nodes. So the IP addresses might not really hide the physical location, but it is an indicator. So users can naturally use obfuscating techniques such as Tor or VPNs or Wi-Fi, public Wi-Fi's, etc. If a blockchain client connects to another blockchain client, we often see the client version. So there's some form of fingerprinting possible. Yet the set size of clients is not that big. So most people are using the most up-to-date versions. Now we can also perform the port scans on these IP addresses and reveal the operating system and more information, and we can, for example, trace which transaction are forwarded, as I just showed in the graph. And if I can see a transaction first from you, you might be the originator, but it's not necessarily the case, right? It could be that the original transaction forwarder received this transaction from some other peer in a private channel. So if you want to go to, for example, block Cipher here, here you can see they are reporting by who this transaction is relayed by. This is notably the term relayed. It does not necessarily mean that this is the real transaction originator. And do you remember the transaction block and hash broadcast mechanism? Right? The elements, the data is typically advertised with a hash first, and then it's requested, and then the transaction block is transmitted. Right? And this all goes over this TCP port 8333 in Bitcoin, or on Ethereum the default port is 30303. So there's been quite some interesting work on how to understand the topology of the network layer. So for example here, so the project Coinscope tries to see if there's a basic positive edge inferring technique between two nodes, right? So you have a node A and you have a node B. And basically what you want to know is whether they are connected to each other, right? And you have here another network participant who is connected to each of them. And then you can perform an active inferring technique. So you, for example, send here transaction P, right? Then you send a transaction M, and then you send here transaction F to this node, right? And you can then observe or infer the mempool of A and of B and understand how they are forwarding transactions. Because, for example, if A is then forwarding a transaction to Coinscope, you could infer that it received this from another peer B, because you only send it to this peer B, and depending on the on the latency and bandwidth between those peers and between these peers here, you can guess how likely it is that there's a particular connection between two peers.